Here we are continuing on with lesson 1.9. This is example number 3. Population of BC has increased by 22% each year since 1981. So we're looking at adding 0.22 to 1 for our base value. And we have an initial population of 2.76 million. Determine an equation for the population of British Columbia. Define the variables that you use. So remember to put let statements for your variables. And then create your equation with that. Okay, I might let P represent the population at British Columbia and N be the number of years since the year 1981. So if N was equal to 0, that would represent the year 1981. If N equals 1, then that would be the year 1982. And if N was 2, that would be the year 1983, and so on from there. So I'm just going to type in some let statements and create my equation here. Okay, so P is your population in millions, and N is the number of years since 1981. And I just clarified that as well, that N equals 0 represents 1981. So coming up with my equation then, I could look at using the population. P would equal 2.76, because population is in millions, so we can leave that as a 2.76. We're going to increase by 22%, so 1 plus 0.22. That's going to give us 1.22 to the exponent of n, where n is our number of years since 1981. So when would the population reach 4.76 million? So this is telling me my p-value is going to be 4.76, and the when is asking me to figure out what n is equal to, and then that number is going to be added to 1981 to get the actual year. So since I'm solving for the exponent, I would put this into Desmos, my y equals 4.76, and then my equation y equals 2.76 times 1.22 to the exponent of n, and find the intersection point of those to find, and then add that value on to 1981 to get the actual year. For part C, what would the population be? So P is unknown. P is asking for the population in 1986. So if we take 1986 and we subtract that 1981, that gives us the difference of 5. So our value of n would equal 5. So I'm going to calculate the population when n is equal to 5. So we just put 5 in where the n is in the equation, put that in the calculator, and we'll get an answer for that. Okay, when I put the part B into Desmos, I came up with an intersection point of 2.741, comma 4.76-ish. Those are rounded answers. So 2.71, if I want to take my 1981 as my base point, and then I'm adding my n, which is my number of years, that's going to give me 1983.741. So during the year 1983, just before 1984, that population will reach 4.76 million. And I'll put a therefore statement there. And when I put this one, part C, into my calculator, I got a 7.46 out of that. So therefore, in 1986, there were 7.46 million people in British Columbia. Okay, so I've put my therefore statements for both of these questions to answer the question that was actually being asked. All right, try example number 4, and I will take that up on the next slide. Okay, so we're talking about caffeine in the system. It's being reduced by 13%. So when I go to find my B value, I'm going to start with a 1, and I'm going to subtract the 0.13. And that will give me 0.87. So that's going to be my base value there. And we're talking about getting an equation that models the percent of caffeine that's left in our system, percent of caffeine left in the system. So when you first consume the caffeine, you've got 100%. We'll assume we start with 100% in the system, and then it's reducing by 13% every hour. All right, so you need some let statements for your variables, and then you can come up with an equation. All All right, I have my let statements here. Capital P is the percentage of caffeine left in my system, and N is the number of hours since it was consumed. So my P, the percent, the initial percent is 100%, and then my base value I figured out to be 0.87, and that will be to the exponent N, where N is the number of hours since it was consumed. Question B here says, when will there be half the original amount left in your system? So when is what we're trying to find. So we're trying to find the N, and we know half the original amount means our P is equal to 50. Okay, so since we know the P and we're trying to solve for the exponent, this would be one you could throw into Desmos to solve for that intersection point and write a therefore statement for that. Part C, what is the percent of caffeine left after 7 hours? So P is what you're trying to solve for, and 7 hours tells us that N is equal to 7. So you can pop that into the equation, and you can throw that into your calculator, and it's going to give you a value for that. Hopefully that all makes sense, and then you've got some duotang work to work on. Okay, so I've shown for part B what my two equations were that I put into Desmos. So these are my two equations. This is the intersection point. So then I can make a conclusion that N is almost equal to 5 here. After 5 hours, only half the caffeine will be remaining in your system. And then when I calculated for part C, I got 37.7. So after 7 hours, there will be about 37.7% of the caffeine remaining in your system.